OMG! It's observed molecular genetics. After completing polymerase chain reaction, PCR, we analyze the results using OMG Gel Electrophoresis. To make a 2% agarose gel in 150 milliliters, we need to add 3 grams of powdered agarose. Here is my 150 milliliters of tris borate acetic acid solution. And I'm going to get approximately 3 grams. That's close enough. And now into the TBE it goes. Now we microwave the TBE agarose solution, keeping a close eye on it because it tends to boil over. Now that all of the agarose has dissolved, all 150 milliliters of it, I will add ethidium bromide, which is carcinogen, which is why I'm wearing gloves and personal protective equipment. Ethidium bromide is a chemical that intercalates or sticks itself between the base pairs in DNA. And when it's bound to DNA like this, it fluoresces. This dye then enables us to see where in the agarose gel all of the DNA winds up after electrophoresis. In this case, I add 1/10,000th the volume of agarose. That's enough dye to visualize all of the DNA that will be on this gel. And now swirl to mix. This is the casting tray for pouring an agarose gel. And we need to clamp it tightly so that we form a 4-sided box for the agarose to be poured into. The next thing that I will need to do is to add combs to this gel. Here's a comb, and the teeth of the comb stick down into the casting tray, and this is what forms wells, or holes or depressions in the gel that become spaces that we can pipette DNA solutions into. And here comes the agarose gel. I pour it slowly to make sure that I don't get bubbles in the gel. I pour the entire volume of the gel. And then we're going to let this gel cool at room temperature until it solidifies. Here's a quick side view of the gel showing that the teeth are submerged into the liquid gel. While the gel is cooling, I'm going to add loading buffer to all of those PCR samples. Remember, these were 10 microliter PCR reactions, and I'm going to use a 6x loading dye, so I need 2 microliters of dye per 10 microliters. That winds up being 2 microliters in 12 total microliters for a 1:6 dilution. In this case, I'm using a bromophenol blue 6X dye. Although it doesn't look blue now, so here's 2 microliters being added to one 10 microliter PCR reaction. And now I add 2 microliters to the rest of the reactions. And we can see that after the dye mixes with liquid, it does turn blue. Now we're going to watch the gel slowly polymerize. Right now you can see through the gel to some of the defects and stains on the bench below it, but watch. As the gel polymerizes and cools, it becomes less transparent and more opaque. And pretty soon you won't be able to see through the gel at all. And when it becomes a consistent bluish opaque color, that's when we know that it's fully polymerized and ready to be used. Like about now. This is an electrophoresis tank and it's filled with buffer. Here's our polymerized gel. So I'm going to remove the gel and its casting tray and place the gel on the casting tray in the buffer tank. You can see it's a nice thick gel. The teeth are well into the gel, so they're going to make good sized depressions or wells to load the DNA into. Here there's just barely enough liquid to cover the gel, and we want the gel to be 1 to 2 millimeters at least submerged. So after I pull the combs out, now you can see all of the little tiny wells that the teeth leave behind, I'm going to add a little bit more buffer to this tank to make sure that the gel is completely covered. So here comes a little bit more of that buffer solution to make sure that the gel is covered. And all of the wells are submerged. I'm going to add 6 microliters of each PCR reaction plus dye to a single well in the agarose gel. This is very difficult. One of the things that the dye does is not just let us see our DNA solution, but it also makes the DNA solution more dense than the buffer so that it sinks into the wells in the gel. It does float out a little. I load the rest of the samples and leave a few gaps for molecular weight ladder. Now we can watch the DNA electrophoresis and the dye is moving towards the red terminal just like DNA will. So the dye lets us watch the progress of the gel. And after about an hour and a half or so, I stop the gel. After electrophoresis, we apply ultraviolet light to observe the DNA bands. Thanks for watching, and please be sure to be in touch if you have any questions.